Alright, hello. Welcome to 4.8 Word Problems. So today we have another fun word problem, and we're going to go through it step by step. We're going to try to visualize what we're doing here. The problem says, Brian plans to buy toys from Amazon. Each toy is $12. There is a $4 shipping fee. How much will it cost Brian to order 4 toys? How much will it be for 6 toys? How many toys can Brian buy with $40? Okay, there's a lot going on here. So if I'm looking at this, I might say to myself, what do I need to find out? Well, first I look for the questions. The first one I see here is, how much will it cost Brian to order 4 toys? So what I like to do is I like to highlight all of the things I need to find out. So this is the first one. I'm going to change its color so I know I'm looking for that. How much will it cost Brian to order 4 toys? Then the second question is, how much will it be for 6 toys? So here's the second question. I need to find out the total cost for 6 toys. And then the last question is, how many toys? Now I'm looking for something different. I'm looking for the number of toys as opposed to the cost. Brian can get with $40. So if Brian has $40, how many toys can he buy? And so what I like to do is I like to reorganize everything so it's in a nicer, easier way for me to remember how to do things. So let's start with the bottom. Let's start pulling things apart. This last question can be the last line down here. And I'm just going to make a list of things so I can visualize everything I need to do. I'm organizing my information, right? So there's one question. Here's another question. Here's the last question, or the first technically. Okay, those are all the things I need to answer, right? And I've even color-coded them. Now let's talk about the information I have. I know Brian plans to buy toys from Amazon. That doesn't really help me in any way. That's great. We don't actually care where he gets it from. Unless in some way Amazon has a discount, and then we do care, but in this case, no. I also know that each of the toys he's going to buy is $12. That seems like a very useful piece of information. I also know that there's something else here. Wait, there is a shipping fee. Now, it doesn't say that there's a shipping fee for each toy. So it's not like if I buy 1 toy, it's $4 shipping. If I buy 2 toys, it's $8 shipping. No. The whole order will have a $4 shipping fee added. So I don't need to worry about that too much. So now the next thing I'm going to do is I'm going to try to figure out one situation in which all the rules are satisfied. So let me draw. I'm going to draw what this order might look like. So each toy is $12, right? So let's just say the toy is a ball. So let's say I buy 1 toy, right? So it's going to be $12 for the toy, which is a ball in this case. Is that it? Is that the whole cost? No. The second part is that there's also a $4 shipping fee. So when I say also, that's a plus, right? So actually, let me not put $4 shipping. Let me put like a tax, right? There's a fee. I'm going to make it look like this. So it's the ball, the toy, plus the fee, right? So the ball or the toy is $12, and the fee is $4. And so that's going to give me the total for 1 ball, right? So 12 plus 4 is what, 16? That's going to be my total cost. And so that's my total cost. Oh, that's Brian's total cost, right? Okay, now let's see what it looks like for 2 toys. And at this point, I'm just trying to figure out, okay, what the situation looks like visually. I'm just trying to visualize what's going on. Let's say it's 2 balls, right? So if it's 2 balls, so it's 2 balls. Each of them is $12. So that's $12 plus the fee. I'm just going to write F for fee, which is $4. That's going to be a total of 12 and 12 is 24. 24 plus 4 is what? 28. So now the total cost comes up to $28 for 2. And so do you see I'm trying to just create a pattern here. Now, if I take this information, which seems to be the rule, right? The whole rule, okay? And I say to myself, look, there's a pattern here. And let's see if I can create an equation to represent the pattern. Okay, so let's call each thing something different. Let's call the cost of the toys or the balls, let's call that C for the cost, right? And the cost is always 12, so that's a fixed number. So it's always going to be $12, the number of toys you have, right? It's 12 times the number. So the first one was 12 times 1, and so it would be, well, actually, it's not. Let's not say it's C then. That's confusing. Let's call it something else. Let's say it's 12 times T, right, for the number of toys. So, for example, here's what I mean. It's always $12 times the number of toys, right? So if it's one toy, it's 12 times one toy. If it's 2 toys like we did, it's 12 times 2. If it's 3 toys, 12 times 3. If it's 4 toys, 12 times 4. So we get that, right? It's $12 multiplied by the number of toys that you're buying. And then here's the next part, plus the fee. Plus the fee. And let's just call it F for fee. And the fee we know is fixed, right? It's a shipping fee of $4. So in fact, we don't have to write F. We could just write the $4 that we know we're going to pay every single time. It's a fixed cost. It means it doesn't change. And that's going to give us the C, which is the total cost. That's what it's. And C is the cost. So our equation looks like this. It's always $12 multiplied by the number of toys we're getting. I'll put that in parentheses to show that they go together. Plus the $4 shipping fee will give you the cost. All right, I'm going to change this into a variable equation. So instead of 12 times t, I'm simply going to say 12t plus 4 equals c, which is the cost. Okay, so now it looks like I have a function, right? Because I could say that c, in reality, is f of x, or f of c. I don't even have to make it f of x. I can make it f of c. F of the cost of, no, it wouldn't be C, would it? It'd be T, because we're replacing the cost, which is really, in reality, what the thing is changing is the toys, right? So it's actually F of T. Actually, I'm thinking now it's not even F. We could literally just say C of T. Look at this. I could go the C, I'm going to make it look like that. The cost of the number of toys T, what we call T, right, is the equation $12 multiplied by how many toys you're buying plus $4, and that will give you the total cost. So in reality, we can create a chart like we did in the last video, and we could say, all right, look, here's the number of toys, right? Here's the equation to find the cost of a number of toys. Let's duplicate that. And the cost, the C of T, which is the output, right? C of T is the output, and that's how much it's going to cost us, right? Cost. And so what we can say is, let's look back at the first question. How much will it cost Brian to order 4 toys, right? And 4 toys is T. The number of toys is 4. So we can start right here. If 4 toys. Then C of t, right, or C of the number of toys, which is 4 in this case, is $12 times t, which is 4 toys. I should make it a different color, huh? Yeah. $12 times the number of toys, t, plus $4 fee. So 12 times 4 is what? Let's get back to our calc. I think it's like 36 or something. 12 times 4 is 48. Whoops. 12 times 4 is 48. So $48 just for the pure cost of the toys, plus $4 for the shipping. $48 plus 4 is what? 52. $52 is how much is the cost of 4 toys, and that's going to be our final answer. It's going to be $52 for 4 toys. That's the first answer. So this first one is $52. Okay, how much will it be for 6 toys? Well, we know that 6 is the number of toys, which is t. So we can say to ourselves, 6, all right, and I can rewrite the equation. The cost of 6 toys, t, is $12, which is the fixed cost for the number of toys, plus $4 shipping. Okay. 12 times 6 is what? I think 72. 12 times 6 is 72. Yay, got that one right. $72. Plus another 4 for shipping. 72 plus 4 is 76. 76. So the cost of 6 toys is $76. $76 for 4 toys. Okay, we got that one. Okay, 40. Sorry, what was it? $76, not 74. All right, and the last question says, how many toys? Now we're looking for T. Can Brian buy with $40? So we already know that C of some number, T, is $40, right? We need to find out how many toys gets us to $40, right? How many can we buy with $40? So if we already know the end, we can go backwards. So if we already know that the cost is $40, C of t is $40, C of t is $40, the cost of the toy is $40. Well, I can first rewrite the equation. C of t equals 12 times the number of toys plus $4. I know that the cost is $40 because that's, well, actually we don't know that's the cost. We just know that we have $40. Let's see how many we can get. So 12t, we don't know the number of toys yet. So now we can just use simple algebra to solve backwards to look for t, the missing variable. So I see I have a plus 4 here. I'm going to subtract 4 on both sides, as I learned to do. I'm going to get 40 minus 4, which is 36, equals 12 times t. Oh, this might come out nicely. 12 times t, the inverse operation is division, so I'm going to divide by 12 on both sides. So this cancels out. T is the number of toys. 36 divided by 12 is 3, I think. 36 divided by 3 is, yep, 12. 36 divided by 12 is 3. So 36 divided by 12 is 3. We are able to get 3 toys with $40. And we can prove that because we know our equation is the cost of this number of toys is 12 times the number of toys plus $4. We know we don't know for a fact, but we believe that it's $3 will get us to 40. Let's see if that's true. Okay. The cost of 3 toys should be 12 times 3, which is 36, plus 4, which is $40. So the cost of 3 toys is in fact $40. Cha-ching, cha-ching. We did it. So how many toys can Brian buy with $40? With $40, he can buy 3 toys. And that's it. And all because we organized our information nice and neat. We drew a picture and then we found a rule or a pattern for the equation that is the function of how many toys to the cost.